Good morning, students. Today we will be going through the session on Inferential Statistics Basics. I am Dr. Sandeep Sugadan. Inferential statistics is otherwise known as statistical inference, is the process of applying statistical methods in order to draw conclusion about the population from the available sets of data which is collected from a sample, otherwise known as analytical statistics. Inferential statistics makes inferences about the population using the data drawn from a sample from that population. First, a sample is selected from the population, data is collected from the sample, data is analyzed. Based on the finding of the data, inferences about the population are made. Inference or prediction of association between a dependent and independent variable is made. Prediction of difference in a dependent variable between two or more groups of independent variables is made. Prediction of linear relationship between two continuous variables are made. So these are the aims of doing inferential statistics. What is a variable? Variable is an element, feature or factor that is liable to vary or change. Variables in a study can be dependent variable or independent variable. Dependent variable is otherwise known as outcome variable, is a factor or phenomenon that is changed by the effect of independent variable. Okay, dependent variable is a factor or phenomenon that is changed by the effect of an associated factor known as independent variable. Dependent variable is a variable whose value depends on independent variable. It is otherwise known as outcome variable. Independent variable is otherwise known as predictor variable. Independent variable is typically the variable which is manipulated or changed so that a change in dependent variable can be made. It is also known as the predictor variable. The dependent variable is the variable which is affected by the changes or manipulations in the independent variable. Some examples of dependent and independent variable. First example is like that. Regular physical activity can affect the variable body mass index. So regular physical activity is the independent variable and body mass index is the dependent variable. Here body mass index is the outcome variable, right? So it is the dependent variable. Regular physical activity is the independent variable. Obesity can lead to the development of type 2 diabetes mellitus. So obesity is the independent variable and type 2 diabetes mellitus is the dependent variable or outcome variable. Same variable can be either dependent or independent variable based on the situation. Inferential statistics checks if there is a real difference in dependent variable in two or more groups. That means if there is a statistically significant difference. Inferential statistics also checks if there is a real association between a dependent and an independent variable. That means there is a statistically significant association. Tests of statistical significance are applied to know if the difference between mean values in two or more groups, the difference between proportion in two or more groups, or The difference in occurrence of disease or problem between two or more groups or categories is statistically significant. Before applying the appropriate statistical test, the researcher need to have a null hypothesis. What is null hypothesis? It is an assumption. Okay, it is a general assumption that there is no relationship or association between dependent and independent variables, or there is no difference between dependent variable in different groups. If there is any difference or association seen, it is due to chance alone. The opposite of null hypothesis is known as alternative hypothesis or the research hypothesis. It is a general statement or assumption that there is a relationship or association between dependent and independent variables, or there is a difference between dependent variable in different groups. Statistical test of significance is applied to prove or disprove the null hypothesis. If, if the uh, test of significance shows that the finding is statistically significant, then we are rejecting the null hypothesis. If the finding is not statistically significant, we are accepting or proving the null hypothesis. Inferential statistics is done by using two types of statistical tests. One type of test is known as parametric test or non-parametric test of statistical significance. Look for the significance value or p-value of the finding. P-value or significance value is the probability to have an association between the dependent variable and the independent variable due to chance alone. P-value or significance value is the probability to have an association between the dependent variable and the independent variable due to chance alone. Another definition is also there. P-value or significance value in other terms is the probability to get the current level of association between the dependent variable and the independent variable if the null hypothesis is actually true in the population. It is a probability to get the current level of association or current finding between the dependent variable and the independent variable if the null hypothesis is actually true in the population. If p-value is less, the association is real. If p-value is more, the association is due to chance. Level of significance is fixed at 0.05. So, if p-value is less than 0.05, the association is statistically significant or real. If p-value is more than 0.05, the association is not statistically significant or not real. If p-value or significance value in the parametric or non-parametric test is less than 5% or less than 0.05, the association or difference is real and not due to chance. So, statistically significant. If p-value or significance value in the parametric or non-parametric test is more than 5% or more than 0.05, the association or difference is considered not real and is due to chance alone, so not statistically significant. Errors in a study. There are many errors that can happen in a study. Okay, So in this table, the top part is null hypothesis is true in the true population, and we are accepting the null hypothesis. Then this study is correct. Okay, null hypothesis is true in the population, and in this study we are accepting the null hypothesis. Then it is correct. Then second one, null hypothesis is true in the population and we are rejecting the null hypothesis. That is an error. That is known as type 1 error or alpha error. Null hypothesis is true in the population, but we are rejecting the null hypothesis. Third scenario is that null hypothesis is false in the population and we are rejecting the null hypothesis. That is, study is correct. Null hypothesis is false in the population and we are rejecting the null hypothesis. Study is correct. Okay. Fourth scenario is null hypothesis is false in this population and we are accepting the null hypothesis. That is an error known as type 2 error or beta error. What is type 1 error or alpha error? Association between height and intelligence. So null hypothesis is actually true in the population. There is no difference between height and intelligence, or there is no association between height and intelligence. So null hypothesis is actually true in the population. And if null hypothesis got rejected in the study, then it is known as type 1 error or alpha error. In your study, you are getting a finding that height is related to intelligence. That means you are you are rejecting the null hypothesis, which is actually true in the population. It is the probability of rejecting the null hypothesis when it is actually true. It should be less than 5% or less than 0.05. That means alpha error should be less than 0.05. Confidence level of a study. What is that? When alpha error is less, confidence level of the study will be more. When alpha error is less than 0.05 or less than 5%, the confidence level is 95% or more. Confidence level is the probability of failing to reject the null hypothesis when it is actually true, or the probability of accepting the null hypothesis when it is actually true in the population. That is a confidence level. Type 2 error, otherwise known as beta error. Okay, look at this example. Association between smoking and lung disease. Null hypothesis is actually false in the population. Why? Because smoking causes lung disease, right? So null hypothesis is actually false in the population. If null hypothesis failed to get rejected or accepted in this study, so in this study you are telling that null hypothesis is accepted and telling that smoking does not cause lung disease. Actually, smoking causes lung disease. So null hypothesis is actually false in the population, but in your study you are telling that null hypothesis is accepted. Then it is known as type 2 error or beta error. The probability of failing to reject the null hypothesis when it is false. Probability of failing to reject the null hypothesis when it is false in the population is known as beta error. It should be less than 20%. Beta error should be less than 20% or less than 0.2. That means power of study should be 80% or more. Power is equal to 1 minus beta error. That is 80% or more it should be. What is power of this study? Association between smoking and lung disease. Null hypothesis is actually false in the population. If null hypothesis rejected in this study, that means power of study is good. The probability of rejecting the null hypothesis when it is false is the power of the study. It should be more than 80%. Beta error should be less than 20% or less than 0.2, while power of study should be 80% or more. Power is equal to 1 minus beta. Hope you understood. Thank you.